today's stream has been a patron request from one of my patrons, who is the yes, there's a stream. Right, so this stream is a request from one of my patrons. His name is Docster, and he asked me to explain the state machine concept for games. So what I'm going to do is we're going to explain the state machine concept, and we'll do a very simple state machine to try and help you visualize what a state machine is. Right? So we're going to use am I going to start at 7? Shut up. Oh, right. So what we're going to do is we're going to use Nico's run game as the example of a state machine, right? So let me load Nico's run in. And what we're going to do is we're going to diagrammatic. We're going to diagramize it. This stream is a state. I can't help it. You wanted to know. Right, let me do this. Let's get the state machine up. Right, so a state machine basically is the concept is that let's see if we can do it. Right, we're gonna. Right, let's put some more data flow. Where's flowcharts? There it is, flowchart. Let's grab that. Right, so a state machine. In a state machine, you have a start point. Right? You have a start point. And what a state machine is that you change from one state to another, right? So in the game, you basically have something that says, I am now in startup mode. I am now in initialization mode. I am now blah, 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 yeah? And so for Nico's run, let's see if we can diagnose Nico's run. So in Nico's run, we have an initial state. Yeah, we have an initial state. Let's pick a proper, yeah, that'll do. Right, so we have initial state. So we've got init game. So we've got a state to initialize the game, all right? And then, let me see where the other stuff is. It's very difficult to try and use Visual Studio Code in a small window. So I can see what's going, so I can make sure I don't miss anything on the screen. Right, here we go. Game logic, it's in game logic. Right, here we go. So we have a state that initializes the game. We also have a state that is dedicated to choose difficulty. Right? We also have a state to initialize the play. What are you guys talking about now? I am sober, I drink beer, my state is now drunk. Yeah, that's exactly the concept. Right, let's put the others in. So we've got reset gameplay. Let's see, we got that. Got that. Got that. Got that one. that one, and that one. Right, let's put them all in now. So this is game running, game paused, Nico dazed, game ended, high score, and instructions. Right, so these are the game states in Nico's run, right? So these are all the game states that are in Nico's run. And we move from one state to the other depending on a set of circumstances. So, welcome my world. Yes, yes. Right, so the way to visualize the state machine is you are in one state. You do something in that state that can say, right, we need to move to this state. So with Nico's run, we have got a state called initialized. That's the very first state. Yeah. The next one is instructions, where we put the instructions on the screen. So basically that's the main menu, the very start main menu. Then we move to game difficulty. Yeah. Then initialize the game, because once you pick the difficulty, you initialize the game. And then we're into game running. And then from game running, we have different states. Right? So if we try, let's put some lines on here. Let's get some lines on here. So we start, we go to initialize. By the way, this drawing package is free in VS Code. It's called Draw.io. Just download the extension. Who needs Visio when you've got Draw.io? And it's free. You need Visio. I used to need Visio, but then when they upped the price on it to be stupid money, didn't need it that much. Didn't need it that much. Right, so here we are. Let's see. Can I reduce this down? Can I reduce this down? Oh, there we go. So when the game's running, we move from different states to... so we can pause the game. So we can pause the game. We can, when the game's paused, we can, we don't do anything else. Game paused, it's just pausing, isn't it? So the next one is when Nico is dazed. Right, because that actually changes from dazed, because if we run out of lives, then we go to the game has ended, and if when the game's ended, if the high score's been beat, we update the high score. Yeah, there's all sorts of different diagrammatic options. Active Directory look, Android, Networking's in here somewhere. UML, that's what I use quite a lot. There's the Azure, that's another one. Cloud and Enterprise, there's a lot in there. Networking, there you go. VM architecture. You got business solution. So workflow, that's the one I use most of all for work because it's workflow. Floor plans, you know, it's very good, saying it don't cost anything. So then we go to high score, and then from high score we go back to high score. Let's put it on that side. This goes back to the instructions. Oh no, it doesn't. It goes to choose a difficulty. And then reset gameplay is reset gameplay. Did we do reset gameplay? Hang on, let me just do a search for that keyword. I don't remember doing it. No, we don't do it. So that's not there. So this is a state machine. Yeah. So this is the main game loop. The main game loop. And we either pause the game, so I might as well put that there. Or he hit a tree, we're into Nico dazed. If you've got enough lives, we continue with the game. If you don't have enough lives, the game gets ended. Test the high score, then we move on to the high score. Once the high score's done, then we go back to the difficulty. So this is a state machine. You are moving from one state to another. Yeah. Now, the state machine that we put into Nico's run is the implementation that Derek Morris had put in his book. Right? And basically that state machine is a... don't want that. It's a loop. Right? So basically it's just a loop round. So your main game loop loops round. Let's get this right. Loops round. Well, that is rubbish, John. Let's do that again. Right, let's do that. I want that to be there. I want that to go up there. 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 Oh! I can't draw to save my life. Hang on. I can't draw to save my life. Ah! I'm trying to do a loop. Let's do this one instead. Get up there. That'll do. It's a loop. It's a loop. And what you do is you loop round through the gate loop and you change a variable with a different state. So we used to do this in Nico's run, right? These are the game states there. And so we had a variable in the storage that was the game state. And in the game loop, you checked the game state. And depending on where the game state, you went off to that area of the game. Yeah? So here, right, so this is the start of the game. This is the main game loop, right? This is the game loop here. That's it, right? And it just runs around that game loop. Just, yes, it is. It's not, yeah, it takes a bit. The problem is I was trying to draw a line back onto itself and yeah, I mean, I can do it. Come here, let's just show it. Right, let's put that there. Right, so I want that to come down there. Right, let's move that to there. Then I want to move that to there. Let's move that to there. No, there. That'll do. Grab that and do that. and then move that to there. There we go. See? Bit of patience, right? So you've got a game loop that goes round and round and round, and all it does is it looks at the game state, and then goes to that bit of the software where you are running the game. So every state just literally runs through, comes back to the game loop, it evaluates it again, carries on. And this is the game loop that Derek Morris had put in his first book, and I think it's in the second book as well. Yes, it is. Where the state machine is driven by the game loop. Yeah. So you could put other things in the game loop, but if you wanted to make it a true state machine, the loop itself is just driving the state machine. The state machine, the variable that holds the state is determining what happens when. Yeah. So if you want it to go to a different part of the game, you just change the state of the game. You don't jump to that bit, you change the state of the game. Because when it comes back here, it loads the state, where it finds where it needs to go in the array, which is this, the game flow array, and then goes off to it. And it means then you don't have to worry about JSRing all over the place. All you do is change the state. Now, in Nico's run, we only had 9 states. We only had 9 states. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, we only had 9 states. Right? But your game can have a much narrower state if you wanted. If you wanted to go down to the more lower level, so to speak, you could have it have 10, 15, 20, 30, 40 states. Yeah? America has 54. No, according to Biden. I know we was classed as the 52nd state or something, weren't we? But you can make your game have a lot more states that govern smaller blocks of code. Yeah. 51st state. Yeah. So so we did in Nico's run. We split it into 9 major states. So we had an initialization of the game state, the instruction state, the choosing the difficulty state, but you could then in those states have substates, or you could just have one big long list of states. But I think Derek did say in his book that if you had too many states, it could become confusing, that you didn't know where you were going. And so what I always it's basically Derek's philosophy is you make your state that describes what it's doing. So, you know, we got initialization state, we have a choose difficulty state, initialize gameplay, the game running state. The game running state is actually the game itself running, but basically it runs through the loop, jumps to the game running state, runs through the entire thing once, then goes back to the game loop, and then does it again. Because in your game flow, you change the state of the game. You don't have to say, if it's this and this and this, go there. You just say, if it's this and this, then I'm going to load this state into that variable. So when the next time it runs through the state machine, when it runs, LDA cream. When it runs through the next time, it knows because you've changed the state, it will go somewhere else. And that's how the paused work. When we pressed in Nico's run P, yeah, when we pressed P in Nico's run, and we can see this, we changed the state. Controls, where's controls? So that's probably the easiest one to show. Let's put that down there. Controls. So where flight mode. Right, where's pause? There we go. So this is doing the pause, and we change, there we go, we changed the state of the game to be paused. Oh, yeah, okay, right, okay. I'm going to bring his eye drops to him. I'm going to bring his eye drops to him, so hopefully he won't get too upset when I've done it. Now, don't get too upset. I may have to sit on him. Hey, buddy. See, took it in his stride. He's got so used to it. So used to it. The eye drops, took it in his stride. Doesn't even. Now the epi Fen. I have a major fight with him with that. He does not like that at all. Right. So next one's 10 o'clock, guys. Next one's 10 o'clock. See? He didn't even flinch, did he? Didn't even flinch. So, as you could, so here is an example of where we changed the state of the game. Yeah. So what we're going to do is we're going to do a small demo. This was Docster's idea on how to try and explain how a state machine works. And what we're going to do a simple state machine, right? We're going to do a simple state machine where we're going to have the game. We're going to have the game loop, and we're going to do 4 things. Just 4 things. Right? So. So we're going to do the player one, mate. We're going to do the player one. The one you said about moving the sprite around using state to do the movements, yeah? So we're going to have the game loop. And in there is going to have the keyboard test. And depending on the keyboard test, we're going to change the state to make it do 4 things. So we're going to get it to go there. go there. So I'm just trying to diagramize. Oh, is that a word? Is that actually a word? I have no idea. So it's going to be a very simple demonstration, which you guys should be able to follow along. Right? So for those people that are struggling with the concept of state machines, you should be able to follow along. Diagonal alley. Right? And the 4 states are going up, going down, going left, going right. They're the 4 states. Yeah? So what we're going to do is that we're going to have some states. Can I put text on here? I thought we could add there we go. So this is going to be state up, state down, state right. Oh, no, that's left, isn't it? Come on. Here we go. State left and state right. You got an original 800. Oh, yeah. I had an 800. Well, I had an X. Well, Tash had an XL. And we got rid of it. I was kicking myself. Should have kept it. Should have kept the XL, but we got rid of it. Right, and so from these states, right, we're going to go. From these states, we're going to have a state that takes us back, which is state stood still. And basically state stood still is the where we're not pressing anything. Oh, idle. Yes, that's a good put. That's it, yeah. Oops. Go back. Yeah, we'll have that. It's a good one. Idle. Put one there. Going that way. Put one there, going that way. Oops. Right, so we're going to have four active states, and we're going to have 5 states in total. So idle, right, left, up and down. Now we could have other states in there where, you know, but where you could have where it's not idle, it's where it's like when you're doing momentum and stuff like that, where your state is actually slowing down. Yeah. So the state is slowing down, which goes through the momentum calculations, which would slow you down. You could have a state where you could have a state for braking, you know, where it would slow you down much faster. A state for acceleration, where you put your finger on and it would accelerate. But we're just doing a simple 5 state machine. So you guys should be able to use this and make it and then use the framework for then to implement into any sort of game. And with Nico's run, we did it in Neptune Lander as well. Neptune Lander had a state machine because it was based off Derek's first book. So look at that as well. So we're going to create a little program just basically to state machine ISM. So we're going to do a simple program to allow us to do it. Now, I haven't got a workbook. Let's grab that and copy that into there. Right, rename this to be 16 and we'll open workspace. There we go. So we should have big, here we go, big letters. Let's open the drawing. There we go. Let's go to that one. That's the one we're doing. Right, so start. Oh, I've got to remember how to start now. Been working too much. US time. 74 hours. 74 hours last week. So how many hours I worked? 74. Lightweight. Lightweight. Yeah, right, okay. Right then. I need a pay rise. Yeah, I wish. I wish. Right, let's create some storage space. So state, in fact, game state. So there's our memory location that's going to hold the state. John only works half a day. Yeah, I wish that was the case last week because I started work at 9 o'clock, didn't finish until midnight. So I did 9 AM to midnight. Thursday I was working until 3 AM, 2 AM, 3 AM, got to bed. So yeah. State machine government owned computers, yeah. Right, so this is our game state. So let's get some states in there. Label, right. So if let's do this properly, yeah. So game, no, state. Let's do this properly. So we'll have an array with state dot, so label, and we'll say init dot label idle dot label going right going up going down. Right, so let's put that there. Right, let's give these some numbers. Yeah, not a problem, mate. I worked I worked American hours last week, from working from 9 till midnight. So I was doing 18-hour days effectively. No, not 18-hour days. 15-hour days. Yeah, 15-hour days. Right, so we're going to have state 1, 2, 3, 4, 5. Why not const? Right. The problem with const is that they need to be imported at the start of the they need to be imported at the start of the game. But when you start subdividing, like we did with Nico's run, yeah, when we start subdividing, see there, I imported constants there, but then when you import them in another thing, like here, let's say in this we have in fact we've got it there. When you import it again, it complains, right? It complains. And also, if you put your constants at the end of the code, it complains again because it runs the constants interpretively. Yeah. So if you define them at the end of the code, it won't assemble. You have to define them at the start. So I've always used labels. It's much easier. Much easier. But you can use constants if you want. But, you know. And also, you can't, with constants, you can't group them like this. You can't group them like that. It won't allow you to do it. And I think constants are global. It doesn't matter what scope you've got going on. As labels can be scoped within code blocks. Oh, yeah, Andy's just said that. Andy's just said that. Right, so first thing we're going to do is we're going to load state.idle, and it's not going to do it, is it? Oh, it's because of the, it's that bug still in it, isn't it? If there's no hash sign, look, it works. As soon as you put the hash sign is. Has there been an update to the extension? Do we know yet? Where are you? Where are you? There. No, there isn't. Still ain't fixed it then. All together now, VS Code is shit. It's not VS Code, it's the extension that's the problem on this. Right, and then we're going to store it in game state. So we're initializing our state machine, yeah? And so what I'm going to do is I'm going to say jump to state machine looper. I'm going to actually call it that, yeah? So you can get your head around it. So state machine looper. So this is the looper, yeah? This is where we're just going to loop round and round and round and round and round. Now, we're going to do the same as what we did with Nico. With Nico's run, we're going to use the same mechanics. Alright? So, you've noticed that we're interferes with your hobby. Yes, I have that problem as well. I have that problem as well. But I would never admit it. Not in front of the boss anyway. But I'm in a lucky position, I suppose, because I like coding. So I code day in, day out, so my work is my hobby. I look at it like that. I look at it like that. Right, so LDY game state. So we're now loading the state of the game, and we are not got 0 is a valid value. Yeah, living the dream for the last 30 odd years. Last 30 odd years. In fact, we'll do that. LDA. Then we're going to multiply it by 2. Because remember, when we have our jump array, we'll be in words, so we need to multiply it by 2. And then we'll transfer it into Y. And then we're going to load the jump address, right? So I'm going to call it game state jump array. All right, going to call it that so you know what to do, what it's going to be like. And once we do that, we'll store that STA in some 0 page somewhere. So what we'll call it, game state indirect jump equals unused 0 page C0. That will do. C0 is unused. So we're going to store it in C0, and then we're going to increase Y, and then we're going to do the same thing again, but plus 1. Now, to make sure that you come back to your state machine, it's all unused. Kill the kernel. I know, mate, but this is just this is just a teaching thing, so we're not going to go into killing kernel and all that. To make sure that we come back to our game loop, we're going to JSR game state subroutine. So we're going to jump to the subroutine. Yeah? And then jump to state.
Hello, John here.
Machine looper.
Thank you for following. Hope you enjoy the stream.
Okay, who's followed? Who's followed? Say hello. Yeah, it's strange.
Ladies and gentlemen, 6502 Kebab has entered the chat.
Hello. Wow. There's no way I'm going to be able to pronounce that. No way. I would not know where to start. See if my bot... Look, my bot works. He's done it. Fabastu. Fubastu. I hope I haven't destroyed your name. I do apologise. I am British, not very good, and Yorkshire at that. Welcome to the stream. Welcome. Right. So, it sounds rude. But it did it, my bot. Look, it's done it. It's got the characters in. Yay, my bot. Fabastu. Welcome. Thank you, Tron, for putting it in simple terms for me. Much appreciated. Right. So this is our state machine looper, right? This is our state machine looper. So what we're going to do is now I need to let me think. We're going to use the control, weren't we? I'm just wondering. No, that's a init. That's idle. That's idle. That state is idle. We can do that. No, is it? Oh, it means invincible in English. All right. Well. Right, so I'm just trying to think. Let's put another one in there. No. We'll do it on the init. Right, so we need the game state array. So, .word. So, let's... I need a placeholder. So what we're going to do, we'll have a placeholder here called return to sender. So that's a placeholder. Alright. So we don't crash the game when we're doing this. Address unknown, yes. Right, so this one is going to be init. So that's the one for init. This one is going to be going, in fact, let's do that. So this one is right, left, up, down, init. And that should be it. They're all the states that we're doing. Right, so we need to build this. Right. So the game states we're JSR into this. Yeah. So here we go. And then we're going to do this. That. We're going to do that. Yeah, that's the one. Elvia. So this is effectively doing a jump go sub. His sister, yeah, his sister. So this is effectively doing a go sub. So we're go subbing to here, which then does the indirect jump to our state function. All right. So let's do the first one. So game idle. And we'll give it its own code base. I have no idea why that has crashed, and I'm who cares. So in game idle, what we're going to do is we're going to check the keyboard. Yeah, we're going to check the keyboard. So we're going to load 197. Yeah. So C5, which is in fact, just to make sure that Andy's happy, which is 197, which is the kernel scan key code. You're never happy. Right, so the first one is 64. This means no key pressed. So if it's equal to 64, then we're going to go to exit. So we're going to have exit down here. Yeah. Exit down here. And we're going to just go RTS. So if no key's pressed, then we're going to go to exit. And I'm just going to make sure I am right that it's just that. Yeah, no key pressed is 64. Yeah. Right. So So it just jumps straight out, and we haven't changed the state. It's still in idle mode. It's still in idle mode, right? So basically, we're not doing anything. We're not acting on it. We've just gone in. We've scanned the keyboard. We've looked at the keyboard scan location. No keys pressed. So we've jumped straight back out, which would then come back to this game state and go back round. All right. In fact, in fact, let's put a delay in there. I've just thought, let's put a delay in there, because if I don't, it's gonna go bonkers, isn't it? So let me put the raster delay in there. I'm trying to find it in Nico's run. I'm trying to find it in Nico's run. Where's the raster? Ah, there. And it's a macro. Oh, good old John made it a macro. Nice. Shift, place. Where are you? Raster. There we go, raster. And raster is DO12. Yeah, DO12. DC09? Is it? Is it? I was going to say. Right, that's just to slow it down, because when we run it, it'll be off the screen. Right. So, next thing we're going to test. Right, so we're going to test for up. So I need to find the scan code key for up. Let me just find it. So we're going to use W for up. W is 9, right? So compare with 9. W equals up. Branch if not equal to next key test. Right, if it's up, then we're going to load state and up, and then we're going to store it in. So what we're going to do is we're going to have a thing called update state, where we're going to do store in game state. Yeah, game state. So jump to update state. Don't you need to set the state in the that is no key pressed? No, because we initialized it there, so it's going to be initialized there, and we're going to set it when we're in the other states. All right. So we're just running through it, yeah. So let's do this. In fact, let's copy that. So down, left, right. Right. So that's up. Then down we'll make S. So S is 13. Whoops. Ooh, wrong place. Yeah, thanks, mate. A, we'll make A to go left, which is 10. And D to go right, which is 18. Right, So now we've got the state, so we can do this. So that we're going to tell the game that we're now in going down state. We're going to, tell the program. We're going to tell the program we're going left in the state, and this one's going right. He needs some escape points for that. Oh dear, there you go, mate. There you go. Thank you. 319. You have plenty of points. I don't think anybody's anywhere near you. Oh, Stuart on 600. How the hell did he get 622? How did he get six? Oh, Saucy's 353. Wow. He cheated. Right, so these then update. We don't need that. Update the game state. That needs to go to exit. That needs to go to exit, because if it's none of those, then we'll go to exit. So we don't need that either. You're not in the points. You was there. You was there. 305 points, mate. Oh, there is a prize. There is a prize. Hang on. Here. Here's the prize. I got one of them made up. So, got one of these made up. So that'll be the prize. So you can have it on your desk and remind you of me. In fact, my camera's too low, isn't it? There you go. They're up there, look. My one's up there. And the Commodore one. There's a couple of them. Do great. Yes, mate. I've already thought about that. So I've asked the guy for some more. So I'm getting some more. But there'll be one for you, mate. I need a shave. Yeah, I was told that earlier on as well. Oh, hang on, looking quite distinguished. Anyway. Right, so in the idle state, we check the keyboard, and then depending on the keyboard, we change the state of the program to make it do the other states, right? So we can do this, copy this, and put it into there. Yeah. So we need to do initialize as well. So let's do game initialize, because we need to initialize the I'm calling it game and it shouldn't be. State in idle. That's better. So let's create another one called state init. But it's in its own code block. Right, so we need LDY hash 63. 64? The Grand OSK of York. Not quite that north. Not quite that north. Further down. Yeah, I'm South Yorkshire. South Yorkshire. The wonderful town of Doncaster. That's where I came from. Right, LDY 64. Yeah. So, store it in 192 star 64 comma y. Oh, I can't do that, can I? Ugh. That's the number I want. Oh, go away. But I need to do -1 because I'm Y's one too many. So DEY. No, I don't. No, I don't. Branch if plus to looper. So that's gonna fill the sprite in. So LDA 192. Store it in 07F8. LDA hash 41231. Store it in. Oh, I haven't got the constant.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Hey, I know that, man. Thank you very much for the bits, mate. Welcome. It's been a while. It's been a while. Doncaster's now a city. Really? Is it now a city? Has it got a cathedral? I didn't think it had a cathedral, did it? Hello.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Tash has done it again. She snuck in there again. No one's having that last cheer spot. Dear. Oh dear. Oh dear. Doesn't need one. All right. Was it a... You have a non-6502 question. All right then, go on, go for it. Let's see if the guys answer you while I'm finding the
Oh my god, more bits? Thank you very much. You guys really spoil me.
Who's done that now? Gary. How far does a light source need to be away not to melt snow? 5, 6, 6, 6. I think it is. If it's the same as ice, it's 6. LDA hash 100. Store it in D000 and store it in.
Oh my god, more bits?
D001.
Thank you very much. You guys really spoil me.
There's a fight going on. Yes, it is a Minecraft thing. It is a Minecraft thing, SP. Saucy. Right, so this is, so we set up and we put the sprite at 100, 100. Right, and then when we've done that, we set it to idle, so we can set this now to start.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Compared to Mike. Oh, he likes VS Code now. Yes, 6. I think it's 5 or 6. I'm trying to remember. It's you'd be definitely safe on 6. I think 5 is the limit. Yeah. When are we writing a C64 Minecraft? Whoa. Whoa, no. No. No, 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 no. Right.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Right. So we should be able to run this. Let's see. This should run. Okay. Which colour? I need to give
Oi,
it...
John, pay attention to chat.
Yes, Docster. Have I missed something? What have I missed?
Oh my god, more bits? Thank you very much. You guys really spoil me.
Gary, is... I did enable it there. I did enable it. That's Sprite 1. I'm just wondering if it's the... I'm just wondering if it's the colour. We'll find out in a minute. Because it's... Oh, it's defaulted to white anyway. Oh, it's not even on. Oh, I know. Right then. What have I done? What have I missed? Come on. What have I missed? Anybody know what? Anybody? Does anybody know what I've done wrong? Come on. If you've been paying attention, come on. Yeah. Didn't put this in. I thought I heard something. I didn't put the jump state in there. That's why we didn't see it. There we go. So there's the block, right? There's the block. So we've initialized the game and it crashed. Why did it crash? It should... Oh, the stack pointer went funny. Where's return sender? The stack pointer went funny.
Oh my god, more bits? Thank you very much. You guys really spoil me.
What he's got? Are they still? Are they still fighting over that last cheer spot? Right. Okay. Let's just check this.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Why would... Why would that be doing that? Let's... The stack pointer was at FD. Then it goes to F3 and then it's F6.
Oh my god, more bits?
Oh.
Thank you very much. You guys really spoil me.
I think it's the interrupt getting in the way. I think it's the interrupt getting in the way. Hey up, someone's moving.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Oh, I like having that camera there. I can keep an eye on him.
Oh my god, more bits?
What is going on?
Thank you very much. You guys really spoil me.
What's going on? Oh dear, hang on.
Oh my god, more bits? Thank you very much. You guys really spoil me.
All I see in the log is Dr. Pav. Thank you for
oh
the
my
500
god, more
bits.
bits? Thank you very much. You guys really spoil me.
And then I've got 1 bit, 2 bit, 1 bit, 1 bit, 3 bits, 4 bits, 5 bits, 1 bit. Oh, Stackbats has got in there. Thank you for the bits, guy. Oh, I'll let you fight it out.
Oh my god, more bits? Thank you very much. You guys really spoil me.
What is going... Oh, dear. Right. I'll concentrate on this while you guys... I think the interrupt's getting in the way. So F3, F6. Yeah, I think the interrupt's getting in the way. F2, that's... F2's there. That's weird. Let me turn the interrupt off. Let me turn the interrupt off. See if the interrupt's getting in the way. FD, F3, F6. Yeah, the interrupt's getting in the way. Right. Now the problem is, because I've set the interrupt, does that mean the key scan's not going to work? Yeah.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Well, if it's not an interrupt, then why is it not doing it once I turn the interrupt off? Let's get rid of that. Let's rem that out and see if that is doing it. Right, FD, F3, straight away, boom. that should be... we've got an RTS there. We've got an RTS there. Too many RTSs. Well, I've only got 2. Right, we'll follow it through, yeah? Right. So we set 5, we jump to this. So this should jump. So JSR's here, jumps away. This is setting up the sprite. Nine, 8, 4, there we go. Then we set up the sprite and then we return back to there. That's right. So now we should be doing the this one. Return back. I don't know. See, that's F6, F4. That's all right. That's doing it all right. I don't know why it would jump back to basic. Unless C0 is used. Hang on. Is C0 used? Well, it's the start address of the load and save, so it should be okay. Alright, let's change the address. I definitely know there's one not used around here somewhere. Here, FB. Right, we'll change it to FB. We'll see if that has it. See if that's the problem. FB. Let's try that. There we go. It was because we're using a 0 page that it didn't like. Right, let's put the raster back in and do it. So we should be, yeah, there we go. We're fine. There we go, we've done it. It didn't like C0. So C0 was being used in basic and we was overwriting it, and so it just threw a fit. Right, okay, so I must have, mate. I must have. Right, so we now need to code the different states. John, it's 10. Oh, it's 10. Right, yeah, okay. Next lot of meds, here we go.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Say hello to your adoring fans. Hey, say hello to your adoring fans. Hey, say hello. Hey, you saying hello? No? Alright, I'll put you down then. Here we go. Ready? Find your feet. Find your feet. There you go. Right side. Oh, Lincolnshire border. Oh, okay. Well, they're up now. Right then. So let's get this thing. So let's do the going right. So in the going right state, we're going to do everything that makes we're going to make the sprite go right. What's going off with the boys? So close, yeah, mate, but so far. So going right is adding into it. So inc DOO. And then load state dot idle, store it in game state. Right, so that's state right. So let's put that in there. Right, so we should say on right, we should be able to go right now. Oh, boom. Why did that not work? State going right. Oh, hang on. No, that's right. I missed the jump state. D. Oh, that's going to 0. Have I put it in the wrong place? Have I got the state wrong? Going right is state 1.
Oh my god, more bits? Thank you very much. You guys really spoil me.
Right, so let's put a breakpoint there because that's where we should be jumping to. Right. Okay, D. D. There we go. Oh, I know. Can you see the problem? Oh, I've done it on all of them. Done it on all of them. Hash. 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 Oops, wrong one. Right. D. There we go. We're going left, right. Yay! Let go, stops. Let go, stops. So we just need to do it with the others as well. So let's do left. So left. So this time we're DCing that and then setting it to idle again. Right, so F6, so now we should be able to go that way, and we are not. And we're not because I'm an idiot. I forgot to put the jump state in. That's why. Now, right, there's left, right, left, let go, stops. Right, let's do up and down. So state up, and that is 1, down, sit,
Oh my god, more bits? Thank you very much. You guys really spoil me.
You're still fighting over that last cheer marker. Right, here we go. So left. Oh, right, I should say. Left. Up. Down. There you go. One state machine. One very simple state machine, but nonetheless, it's a state machine. So, as we put in this diagram, we have our looper that doesn't have the keyboard test in anymore because we've added another state, didn't we? So let's add that other state in. We have another state called idle, which checks keyboard. Oh, they got back in the beds, have they? So there we go. It's got an extra one.
Oh my god, more bits? Thank you very much. You guys really spoil me.
What do you mean up is wrong? DO01. It worked. It worked. Right, so there's our state machine. So our looper, that's the control looper, yeah? That then goes to the different states. So we've got state left, which makes us go left, state right, which makes us go right, state up, which makes us go up, and state down, which makes us go down. Once we've gone down, we set it back to idle, yeah? So idle is now coming here, yeah? Because now we've got an extra state called idle. So all these idle states now come to here. So let's make sure that they're right. Get this diagram.
Oh my god, more bits? Thank you very much. You guys really spoil me.
God, you're fighting over that last cheer. And then this one, we'll move it to that side. Move it to down there. Grab that. Move that there. Grab that. Move that there. Right, so this is the state machine now that we've got in this program, right? So we have our looper that goes off to the different states, yeah? And we will turn that around. There we go. Turn that around. Right. So in the looper we know what the state is. The initial state is idle. Yeah. So our initial state is idle. So if we put something there, start Oh, it's init, isn't it? Oh, we got the init state, haven't we? Let's do that. Let's put the init state in. In fact, it's the other way around, isn't it? It's that way. And then that initial state goes to, you guessed it, idle. So we'll put it down there. We'll grab that, put that up there somewhere so we can get to that bit. Put that there. That bit can come down here. And then that bit can do that. So our init state goes, initializes the program and then sets it to idle, which then sends it to this state here. This then checks the keyboard and sends it back to the looper because we've set the state, which then goes off to the different states. Yeah, in fact, that's both ways. Alright, so this is the basic concept of a state machine. So you do not tell it where to go. All you're doing is setting the state to what you want it to do, and then let your looper, your main game looper, which is that, do the job. So it goes off to the relative state. So we've done it here for basically moving something around the screen. So we've got states to move around the screen. So we've got the idle state. This is the idle state where it checks the keyboard. Have we got anything? No, we haven't. Right, we're still in idle state. As soon as we press a key, we've now gone into go right state, which means that the sprite is going right. As soon as we let go, we're back into the idle state, because when we've done gone right, the first thing we do is go idle, which then goes back to the keyboard check routine. Notice I've still got the finger on the D, which tells it to go right. Same with left. Yeah, well, I've still got my finger on the keyboard, it's going left, but it's still going through the idle check routine, because when we go left, we set it to idle. And same with up and down, yeah? On state go to, yes. Go sub, yes, that's the basic equivalent. So as Andy's put, the basic equivalent would be on state go sub. You know. Except like that. So I hope this is put this is giving you some understanding of how a state machine works. Well, on state go sub is a vintage switch, yes, and it's same with on state go to, because there's on state go to in basic as well. But I hope this gives you a basic understanding of how a state machine works, how you can implement a state machine easily, because it's not rocket science. All you've got to do is just make sure that all your state jump array is set up right. As even I got it wrong, forgot to change it, and also make sure you do have a return to sender. That if any of the states have not been implemented, this is the default jump, yeah. But that's as simple as it gets, and so you can make your states machines as complicated or simple as you like. So this is Nico's run. We've got a full game based on this state machine, a full game. The states are not, you know, atomic level. It's computer science, yeah. The states, you can make the state machine go down to the atomic level. You could say have a state called read keyboard, have a state called update bad guys, have a state called this, have a state called that if you wanted, or you can have more generic states like we have in Nico's run, where we have the states that say choose the difficulty, Nico's dazed, game over, and stuff like that. It's more high level, yeah. So is switch case in C classed as a state machine then? If you have in the switch a lot of, if in the switch you get it to do a function, yeah, then yes. But if most people use switches just
Oh my god, more bits? Thank you very much. You guys really spoil me.
You still guys are still fighting over that last year. But yes, the switch stroke case could be classed as a state machine if you put a function in the switch, yeah, that changes the state of the variable that you are doing the switch over, yeah. Then you could say it's a state machine. So I hope that helps. A state machine is useful if you're going to be jumping from one place to another and you don't want to have to remember where you're going to. What you do, you just change the state, send it back to the state evaluator and let it do the next state. It means you don't have to worry about, I'm go subbing to over there, that means I'm going to be coming back here. What do I do after that? All you're doing is saying, right, I'm going to change the state, let it finish its function, and let the state evaluation system then do that. Never used indirect jumps before. I love indirect jumps, especially when you pretend to make them go subs. Yeah, because that's what this is doing. It's doing we're doing a go sub to this that then does the indirect jump, and as long as you've got the RTS in your routine that you're indirect jumping to, it's a very slick way of doing on state go subs, on go subs. State machines are also the core regex. Yes, that's true. That's true. But I'm not describing regex to anybody. It's bad enough me trying to work it out. Indirect, yes. If you don't implement it correctly, indirect jumps can take a long time to figure out what's going wrong. A long time. John, can you explain regex in the next stream? No. No. I'm not gonna do that. No. Regex are good, but I'm not. It takes me all my time just to figure it out. Regex is all about sets. You know, set algorithm, set.
Oh my god, more bits? Thank you very much. You guys really spoil me.
I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.